And good evening. Good evening.
I was
Hello.
enjoying the song so much I didn't want it to stop.
Hey everybody, how you doing? Good evening, everyone. It's welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Hey,
Hey,
hey.
hey.
First of all, I'd like to welcome back our regular co-host, Mr. Paul Owen from Royal Astronomical Society of Canada and the Moonshadow Observatory in beautiful Hampton, New Brunswick.
Hampton, New Brunswick. Yeah.
Hey. And picture us, please.
And Royal Astronomical Society of Canada member, New Brunswick chapter member from the PFO Observatory here in St. John, Mr. Mike Powell.
Hey.
Yay!
Oh, where is he? Oh, he's
Down
here.
that way, yeah.
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 You guys are this way.
All righty. Well, tonight we have another full show planned for you. And tonight's show has mostly just one topic, Mars.
Mars.
Mars has been a busy place for spacecraft over the last week or so, if you've been paying attention, with 3 new missions visiting the red planet recently. Each of those missions now has a part to play in helping us to understand the history and the conditions on Mars. We saw both the Chinese led Tianwen-1 spacecraft and the UAE's Hope spacecraft successfully enter orbit. And of course, we watched as NASA's Perseverance rover successfully touched down on the surface of Mars on Thursday. So tonight we're going to take a closer look at all 3 missions and the science on board, what they hope to achieve, and more. Mike is going to be introducing us to China's Tianwen-1. Tianwen-1. There we go.
Hi, China's Rover. I'll do that.
Thank you. Paul's is a lot easier, Hope. Paul will be discussing the United Arab Emirates Hope mission, and I'll be offering some information on NASA's Perseverance rover mission.
I hope to. So long as Chris perseveres.
We will. We'll get them all in. We're also going to have another interesting Rosanna's Fun Facts tonight. That's tying us into Mars as well. And, of course, all of your wonderful photo submissions that you submitted throughout the week. And, as always, we're going to take all your questions on telescopes, binoculars, stargazing, and more if you have any. So sit back and enjoy, folks. Remember, this is a live broadcast, and it's family-friendly, too. So if you have any questions about the night sky, we're happy to try to answer them here for you. So let's get started with some discussion on the red planet. We're going to start with Mike, I guess. Mike's going to give us his presentation on Tianwen. Tianwen-1.
I was going to say, no matter who's racing to Mars, Tianwen won.
Wah, wah.
Maybe you persevere to hope for that.
Okay.
See if I can get this right. I want to do this screen, and then I'm going to pull up this. Tell me what you see.
China's first Mars mission. So we're going to, I'll pin your presentation there, Mike. There we go.
Excellent.
You are pinned. Consider yourself pinned.
I have been duly pinned. So China's first mission to Mars, and it's actually the Tianwen-1. I used to have a Vietnamese fellow that worked for me, and his name was Tian. So that's how I know how to pronounce it, actually. So Tianwen-1 is China's first mission to Mars. Tianwen-1 is China's first independent interplanetary mission. They've never done anything like this before. It draws its name from history, with Tianwen meaning heavenly questions or questions to heaven. And that was taken from a poem written by Q Wan around 340 to 378 BC. It actually launched on July 23rd, 2020, from the Wenchang spacecraft launch site, which is China's Kennedy Space Center, I guess. It's their largest rocket facility. Now, the funny part was this: they never had a name for the rover at launch. Like Perseverance and Curiosity, they were all named long before they left the Earth. China didn't. What they did do is pick 9 names, and China's holding a 40-day public vote to select the name for its Mars rover, which is currently closing in, actually in orbit now on the red planet, but it should be voted on by the end of February 2021. Isn't that weird?
Yeah.
So she launched. It took them 7 months or 55 million kilometers to get to Mars. And they're going to drop a rover just like the Americans did. They're going to analyze the soil and atmosphere, capture some images, chart maps, study the composition of soil and rocks, and look for water and past signs of life. Now, this rover is very similar to the American rover, but you think that it would be a simple thing to get to Mars. And actually, it's quite difficult. When they launched, if you can see the orbits here, the Earth was actually riding behind Mars. And they launched. But it takes so long to get to it that by the time the 7 months was up, Earth had passed Mars. We're all the way around to the other side of the sun, and Mars is a little bit behind. But during that shot to Mars, they made a whole bunch of these TCMs, which are trajectory correction maneuvers. And that's just to make sure it stayed on target the whole time it was on its way to Mars. Now, you think when they get to Mars, they would go straight into normal orbit. And no, they've got this other plan. They've got about 5 actual different orbits that they're going to go into. Some of them are going to last a week or two. Some of them are just going to last a few hours. So there's first when they come in, they're going to get into an orbit and make sure that everything is working properly. And that's going to be basically, I think it is where do we go here? The blue one. That is a 10-day orbit that it's going to be going around. So it's going to take 10 days to do this elliptical orbit. From there, they're going to switch down, and they're going to go into a 2-day orbit. And again, they're going to make sure everything is getting ready. And at that point, they're going to get ready to launch the lander. Then they're going to drop down into a 3rd orbit, which is going to be approximately 8.2 hours to do a full orbit. They're going to drop the lander at that point. And then the orbiter itself is going to go into a last orbit that's going to be a 7.8-hour orbit. So why they're doing all these different orbits is beyond me, but that's what they've got planned. Now, China not only put money into the rockets and the orbiter and everything else, but their whole plan for going into outer space, they built an enormously large ground-based antenna network. And these antennas are not small. These things are huge. So they're planning something for the future that, we haven't seen the likes of because the antenna array is massive. And that costs a lot of money. So they're putting piles and piles and piles of money into this project to start and then, of course, continue from there. Mm-hmm. So what have they done since the launch? Because it was launched back in February last year. Well, they found it with a telescope and took a picture of it right here on its way to Mars, which is pretty cool.
Wow, that is cool.
So then it turned around and basically took a picture of the Earth and the Moon. But the cameras are calibrated to take images when they get close to Mars, so that's why it's actually out of focus. But it did take a picture of home. Now here's a neat one. It took a selfie. So the Mars probe has a little tiny camera on board that was actually ejected from the orbiter, and as it was floating away at 15 million miles from Earth, it took a selfie to send back to Earth. And what that was basically for was to check and make sure the solar panels open wide, the cone was still on, the lander, the radar antenna and all that was open properly and no parts were missing. So it took several selfies, but this was probably the coolest one I picked out of the bunch. Now, what other orbiter takes a selfie on its way to Mars? And when it got into Mars' closest approach on February 5th, of course, now the cameras were calibrated for that kind of a distance, and it got its first picture of Mars moving in. And that itself is a feat. They made it. And then finally, it went into orbit on February 10th, 2021. And it just showed a picture as it's coming, actually into orbit. So it's been quite a trip since July 23rd, 2020, when it was launched. the probe went on its way. It took some selfies, took some pictures on the way back, and then finally got into orbit on February the 10th of, well, this month. What happens next? The intention, like the Americans, is to land the rover and the lander on the surface sometime in May of 2021. Like I said, they got some other stuff they want to do before they attempt to land it, but they were talking end of March, early May, so that remains to be seen. How's it going to land? Well, it's coming down. Surprisingly enough, does this look familiar?
Yeah.
Come into the atmosphere, do a full burn. At 7 miles up, it's going to launch a parachute and slow itself down. At 5 miles up, it's going to drop the heat shield, and then the radar is going to start picking up the ground. At 1 mile up, it's going to drop the sky crane. It's going to go down to 66 feet, lower the rover onto the surface, break off, and then fly away so it doesn't get in the way of the rover and crash somewhere else and leave a little bit of litter on Mars like the Americans do.
Hey, that's my slide.
Very similar to what was just went on here this past week. There's three main parts. There's the lander, the rover, and the orbiter. Sounds familiar. The orbiter is basically going to go around. It's going to map the surface, take pictures, and it's going to relay the communication between the rover back to the Earth. The lander is basically the part that brings the rover down. It's got two little ramps on it. It'll drive off, and then the rover will do its thing. But the lander has some instruments on it as well, like barometric pressure, temperature, and all that kind of stuff. And then the rover itself is similar to the American rover, and it's got things on it like particle analyzers, magnetometer, subsurface radar, and all kinds of goodies on it. And it's going to drive around for 90 days. And that's all it's designed to last for, 90 days. And do its thing and send the information back to Earth. So, in May, when they finally do decide to drop the rover and the lander down, this is what we're hoping to see. This is an artist's impression. And you'll see the lander with the two ramps on it and the rover sitting to the side, hopefully successfully driven off and sitting on the surface of Mars. And same with the lander with all its equipment on it, still hopefully sitting on the surface of Mars. We don't want to see this. So if they're successful and they land, that's the point we want to see. Now, you may think, okay, the Americans do it. It's not an issue. Excuse me. It's not a problem. And I know you can't read everything on here. This slide I just wanted to quickly show you. Since 1960 to 2018, there's been 45 missions to Mars. 22 have failed. Or excuse me, 23 have failed. So more than half of those were failures. They didn't make it. Now, out of the 22 successful ones that are in black, some of those were called successful failures. Because, yes, they did land something. Maybe the temperature probes and things worked, but the cameras didn't, or vice versa. The cameras worked and other instruments didn't. So they called them successful failures. But going to Mars, and some believe it's cursed, is a very, very, very difficult thing to do. And you spend billions and you get one shot at it. So far, the Americans have done well. We went through the 7 minutes of hell, and they landed. And Tianwen-1 is going to be doing its thing in early May, and hopefully it'll get through it, and it'll turn out to be one of the black lines on the next list and not one of the red lines on the next list, because it's a very, very difficult thing to do. And hopefully the study will continue, and we'll hear more from them. And that's all I got on Tianwen-1.
Wow.
Awesome, Mike.
Pretty quick.
So, yeah, that looked a lot like the Spirit and Opportunity rover when they were on the surface. And you already did one of my slides. I don't have to talk about
the upside down one?
Yeah. They looked at 3 months for Curiosity, right? Not Curiosity, I'm sorry, but Spirit and Opportunity. And Opportunity actually lasted 15 years.
Exactly.
So 60 times the warranty. Wow, if I could get that on my car, I would never have to buy another one.
Yeah, exactly. It's a lot of money spent for 90 days.
It sure is, yeah. And the value will be just, I mean, we've got so much data now from Mars, so just keeps going, gets better and better. Hey, we're going to say hi to Paul Crowder there from the UK. Welcome, Paul.
Hey, Paul.
Hey, how you doing?
Love your show. Great job, guys. Hey, thanks very much for your support. We got Alan, Legier, Maggie, and Renat on YouTube, and we have another whole bunch here on Facebook, which I'll get to as well. We're going to go right on to our next talk because we also I didn't mention, but these two guys also have the moon right now live in their telescopes. So if we can move along through this through our talks here, we might get enough time at the end to be able to offer a live view of the moon as well. So bear with us, folks. We might be a little bit longer than an hour tonight, but hopefully you'll stay tuned in. So, all right, Paul, do you want to scoop up?
My scope should just completing the meridian flip as we speak.
Awesome. Okay.
So we should be able to offer the moon. I'm just curious to see if it's going to land. Well, it's not going to land on the moon, but if it's going to land at the moon.
Curiosity.
Do the meridian. Do the meridian. Do.
Oh, that's just unbelievable. It flipped over, and now the moon is right where it was when we started, except it's upside down.
Oh, well, it's upside down somewhere.
It's lovely. Well, I'm excited about that now.
There you go.
Okay, so you're going to do Rosanna's first? Rosanna fun facts?
Yeah, we're going to do some stuff like that, I think. So let me see if I get myself set up here first off. And see, I'm going to try something a little different tonight. So this, I might fall flat in my face and I might not. We're going to find out. All right, so I guess I better share. And that one. And this is tonight's
Rosanna's Fun Fact.
Wow. He does that well, doesn't he, Mike?
He does it so well.
Rosanna, welcome back for another great episode of Fun Facts from our friend Rosanna. And so Rosanna always writes her fun facts, and they're always so timely. And so this week's, she says, when you first learned, actually, I was supposed to play a little clip, and I'm going to see if I can do it first before you get into this. See if we can do that. To build intrigue. All right. Da, 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 da. Ba, da, da, da. Da, da,
I'm intrigued.
all right. And that was all the glory of Mars to build up to Rosanna's fun fact this week.
That was? Hey, good job.
Love it. Okay,
effects.
so let's get right into it. So it says, when you first learned about the planets and the solar system in school, did you pick a favorite? Mars is a favorite for many, but actually comes up as the third in a Google search of list of top 10s. But they did. But did they ask everybody? Mars is in the news this week. I can't read today, and I hope everybody watched Perseverance with either live or later. I did, even though I was working, and I watched with my students. Music and astronomy totally go together in my world. Thinking of all the pop songs involving Mars or the classical piece by Holst, which introduced this fun fact, my student and I and everyone at Morris Music cheered. But remember, this is not the first landing. The Viking landers touched down on Mars back in 1976.
It's a good year.
So humans may actually get to Mars sooner than any of us ever thought or believed possible. Elon Musk thinks colonization can begin in 10 years. So this is Rosanna's Mars dust globe. Isn't that cool?
I like it.
I like it too. So waiting to get to Mars may seem interminable, and certainly the getting there will take a while, at least 9 months one way. Oh, I love this. Oh, I can't read what it says on the top, but of Mars in 10 years. You mean I'm stuck here through 2 more of these election cycles? I love it. But before escaping COVID and politics and signing that contract for a stay on Mars, you need to be aware of how long 1 year on Mars actually is. The Mars year is 687 Earth days. A day is almost like our day, 24 hours plus 37 to 39 minutes. Sources vary. So the Mars year holds 670.24390 Mars days. It will be much easier to follow our calendar while you are there. Pack more than one. Mars year 1 began at northern vernal equinox, solar latitude 0, on April the 11th, 1955. So that's when we started charting it, apparently. So although Mars is a few billion years old, humans decided to start counting Mars years on April the 11th, 1955. If you share that birthday with Mars, you are actually only 36 years old. Why did we pick the northern vernal equinox? According to Fraser Cain, an important question is at what point in Mars' spin around the sun does the year actually start? Astronomers have decided that the northern equinox marks the start of a new Martian year. This point is the beginning of spring in the northern hemisphere and autumn in the southern. That at least makes more sense than the arbitrary date slightly after the beginning of a winter that our species has picked up for at least most of Earth's hemispheres to begin a new year. So there's a new year on Mars. February the 7th, 2021 marks the start of a new year on Mars. Years are measured in a similar way as Earth, but there are a few differences. So Mars 1 year was designated after an important dust storm in 1956. And a day on Mars is called a sol, and approximately 24 hours and 39 minutes. It is slightly longer than an Earth day. And so you can see by this little graph up here, that's basically 365 days for Earth to go around. Because Mars, of course, is further out, larger orbit. It takes pretty much twice that. So you can count on 2 years for a 1 year span here on Earth. So this week's Kurt's Sky at a Glance, he mentioned some neat Mars comparisons while you were checking out the night sky with Orion and Taurus up high in the evening. Compare the color of the red giant stars Betelgeuse and Aldebaran with that of Mars to the west. Betelgeuse is a little brighter than Mars, and Aldebaran currently is a little dimmer. So spend a little of your earthly time this week checking out that 36-year-old planet Mars. And that is this week's
Rosanna's Fun Fact.
Yay!
Yeah,
Awesome. Yay.
Another good fun fact from Rosanna. Thank you very much, and very, very timely as usual.
Absolutely. I like it.
Yeah.
Okay, let's get quickly to a few photos that were sent in, and then we're going to go on to another talk about Mars. We got 2 more talks about Mars to talk to discuss. Well, and then we've got a live view of the moon, hopefully, for you folks out there in internet land. Okay, let's bring up some photos. I think I can just without no, I got to share my screen. That's right. Hang on, because the people out there won't get to see it. Where's my mouse? There it is. I got to make the mouse like about this big on the screen because I just present now, entire screen. I'm probably going to do this one. Okay, let's see what we got here. Make sure this one pops up. Oop, didn't pop up in the right spot, of course. Let's try this. There. How's that?
Good.
Okay, got it. Good. Hey, this one's from Stefan Picard, and Stefan says, "Hi, Chris. A quick stacked shot of the southern hemisphere of the moon on Friday night. Made it a fun exercise to try and identify the prominent craters. More challenging than I thought it would be. Maginius is 155 kilometers driving distance from St. John de Moncton. So, yeah, that's that guy. St. John de Moncton. Could fit inside that.
Wow. Where's Sussex?
Wow.
Well, yeah, probably down here. Sausalito.
Okay. There you go.
Yeah, awesome shot there, Stefan. And Stefan has been quite busy with his photos.
Yes,
He's been out quite a
That's
bit.
awesome.
Yeah. Here's another
We got
one.
one, as they say.
Yeah. Here's another one he's got. Hope you had a great week. Great broadcast this week. Just a couple of DSLR captures from this past week or so. One has Orion and also Sirius showing its dominant brightness. Rigel also shows great brilliance. I guess that's what we've got here. And then the second one, the other one he said we've seen on Facebook capturing number 1 would have been Uranus down here. Mars was number 2. And 3 with the Pleiades. Awesome. And the moon. Only after did I notice that I had captured the Pleiades at the edge of my field of view. So let's take a look at his other photo here. And there's this, no, is that the right one? Hang on now. Try it this way. Yeah, it's the same one. I think. Hang on. I get too many screens. Let's do this. Yep, looks like the same shot. There we go. Okay. That one has Orion and Sirius, so yeah, nice shot. So there's Orion, of course, and Sirius down here to the left-hand side, the brightest star in the sky. Brightest star in the night sky. Got that one? Okay, let's keep going. Sometimes when if you're a friend of mine on Facebook, sometimes I'll go in and I'll steal some of your photos. So just be prepared to show them. So yeah, I'll go in and scavenge some photos if I'm running a little bit short on some of them. So hey, Robert, how you doing? Grab a couple of yours. We've got Ryan sitting here.
Just flip that, Chris. Just go to your go up there by your button on the top of that picture. And that little button, press that.
This one?
No, over right next to the heart.
The rotate.
Oh, that one. Okay.
Yeah. You might have to do it a couple times. Two more times. Once more.
Back where we were.
I'm
not sure.
We've definitely gone full circle.
Well, there's Betelgeuse, and there's Rigel, and there's the 3 stars, and there's the sword.
Yeah.
So.
Right on.
Yeah, very nice. It's nice too to see Betelgeuse in that nice orangey color, eh?
Yeah.
It's so recognizable.
Yeah. Let's hope it gets real recognizable sometime, goes supernova. Anyway, there's Orion down here. He's got as well. He had the moon. He's got the Pleiades in there. He's got the Hyades in there. And I think he's got Mars in there too. Moon, Hyades, Pleiades, Mars, and Orion. So Mars must be up in here somewhere. Anyway, great shot. Nice to capture that much in one shot, right?
It is.
Yeah. Yeah, that's a lot going on there.
Thanks, Robert. Nah. Okay, we just got this one from Cheryl Stevens. Cheryl Stevens. She just captured this tonight. She sent this in a little bit late. She says, "Hi, Chris. I haven't taken any moon pics in these winter months, but I was outside today and noticed this easy capture around 5 p.m. tonight.
That's awesome.
Thanks for all the great work you guys do for all of us. I know you guys are all keeping a close eye on what's happening on Mars for sure. So thanks, Cheryl. And gee, I don't know where's this one come from?
Oh, geez. It's a bunch of dots.
It's a Messier 38. See, I told you guys to be careful what you post. Because if I'm running a little low, I might be scavenging. There we go. This is a capture from Mike's repertoire of Messier 38. A nice open cluster. Great shot, Mike.
That's really nice.
Lots of clarity there.
Oh my goodness. Love the clusters, eh?
Oh, so many stars. So many stars.
That's it. And where's this one from?
Yeah, there you go.
Oh, so this is Mr. Owen's capture of Messier 33.
Is this one not famous now too?
I believe it is, because this one was on the skynews.ca website
That's
today
the one.
for the Messier Marathon. So congratulations, Paul, for another excellent chance at exposure there for another beautiful photo.
Well done.
Well done, yeah.
Well done.
Awesome.
Thank you.
So that's on skynews.ca. You'll find that.
Yeah, that's this week's article. It's a really good article. It's written by the fellow that does the show with
Chris Vaughn?
Chris Vaughn. Yeah, Chris
Yep.
Vaughn does a whole on how to find. Like for example, you got to know exactly the dates because it's around a very specific date to be able to pull off this. And he explains where to start in the night sky and basically the time that it takes. And throughout the night, he gives you different instructions as to where to look for the next items. So it's a very well done article.
Awesome. No, it's so it's a great photo to go with it. Yeah, it's all about the Messier Marathon, right? So that's coming up soon. This one just captured. I just got this one tonight on my phone. Actually, Kathy Adams sent this one in to me. She says, "This is my first picture with my new telescope."
Oh, sweet!
Not bad, eh?
Excellent.
Awesome.
Uh,
That's terrific.
she said a chance meeting with Robert Gadet started this hobby.
There you go.
Well, you can't blame us for that one. So
Way to go, Robert.
yeah,
He had a chance meeting with us.
he did. There it is. Really
That's
nice.
fantastic.
Awesome. I gotta know what scope you're using, Kathy. Great shots.
Yeah, interesting to see. It's a beautiful image.
So let's, okay, so if anybody would like to send in a photo, we would love to get them right here at Sunday Night Astronomy Show at gmail.com. You can send them in there, send them into my Facebook page, send them as a message, put them in as a text message, I don't care. Drop them in my mailbox, whatever you like. Happy to get them. So let's carry on out of that, and I'll stop presenting. And there.
No, that's all.
That's that part.
That's all I got to say about that guy.
I've got to say
That's
about
all she
that.
wrote.
Life's like a box of chocolates.
You know, there's been a lot of stuff going on in the last little while in space, hasn't there? Really, when you think about all the things that we've kind of been watching and how things are evolving.
It's nice to get back to it.
It's
This one for so long.
yeah, it's the discovery exploration that we're going. We got Juno, Juno at Jupiter right now. We had Cassini at Saturn. We've got the LRO, Lunar Reconnaissance Orbiter, still orbiting the moon after 12 years. We got the 2 Voyager spacecrafts way out there after 45 years. We're still talking to them daily. Like that's amazing. And then we got the Hubble still up there. We've got the solar probe, Parker Solar Probe, that's getting in close. It's going to touch the sun, it says. So we've got all kinds of stuff happening. They're talking about another Venus probe. There's going to be they're talking about a Europa clipper that's going to go out to the moon of Europa. So there's all kinds. So if I was a young person today, I'd do everything I could to get myself sitting at JPL. Because these people spend their lifetimes on this for sure. But look at the reward of working on a project like these Mars Perseverance rovers, and there are people on there that are the rover drivers. What do you do for a living? Oh, I drive a rover on Mars. Oh, cool.
You got it stuck in the ditch.
Yeah. You don't want to be that guy. Okay, we're into 8:34, so we got to get Paul. Do you want to do your talk?
Okay.
Okay. And then I'm going to follow up with the Mars Perseverance after that.
All right. Let's see if I can do this now. So bear with me. Where'd my talk go? There it is.
Renat was asking if that's Chris Vaughn. Yes, it is. Renat.
Yes. Yes.
He's called Astro Geo Guy. That's his handle.
That's the dude.
That's the guy.
All right. I'm just going to try to get this up on the screen, and I'm going to present.
Oh, Kathy has a Celestron 6 SE. Thank you, Kathy. Okay, perfect. Go ahead.
Nice scope. I know what they're like.
So
Okay. Sorry.
I'm just going to pin that, Paul. Here we go. Okay, you're pinned.
Okay, thanks. Okay, so basically, I'm going to be talking tonight about the Hope space probe, And this one, like Mike's talk earlier, this is the first time for the aerospace mission to actually have something like this all on their own and getting something out to Mars. And it's just absolutely incredible. So what you're looking at here, first of all, is before it even got out there, is they had to ship this thing carefully and over to the launch site. So the transfer operation saw Antonov 124 heavy lift carry the spacecraft in a specialized temperature and atmosphere control container from Maktoum International Airport in the Emirates to Chubu Centaur International Airport in Nagoya, Japan. Now the spacecraft was then loaded into a sea freighter, carried to Tanagashima's Shimane seaport, and then transferred by night to the launch site. Now the Emirates Mars mission was conceived to disrupt and accelerate the development of the UAE's space sector, education and science community led by MBRSC under the supervision of the UAE Space Agency. The mission will send the Mars Hope probe to orbit Mars in February, which it has certainly, it's already been there, and it's already in its we'll call it trial orbit. And Hope aims to build the first full picture of Mars climate throughout the Martian year. So that's that photo. And then we'll move on to the next one, perhaps. So basically, this is, if I can make this a little bit bigger, actually, or do I have another slide? No, this is it. This is the probe. So this is actually, and I'm going to try to make this a little bigger so you can see what's going on with this. So this is what they've actually sent up. So this is what they call the Hope Spacecraft. And its job, unlike the other two that you're going to hear about tonight, or that you have heard and you will hear about, those two are actually landing on the surface, collecting samples. What this one is doing is actually staying in orbit. So it's actually not landing on the surface at all. It's going to be basically orbiting Mars, and it's going to be taking samples through spectrometer. So it's using an infrared spectrometer, and that actually will measure the global thermal structure and abundances of water, ice, water vapor, and dust in the Mars atmosphere. And then that the other device it has right here, the second one, is a ultraviolet spectrometer, and that measures global characteristics and variability of thermosphere and hydrogen and oxygen. And then they have an actual camera, which is this one right here, and this measures properties of water, ice, dust, and aerosols, and abundance of ozone in Mars's atmosphere. Now, these solar panels that you see here are 600 watts each. And with all three of them up and running and fully charged, they have enough power to run about 20 laptops. So it doesn't take a whole lot of energy once you're in orbit to do what this thing has to do. Now, it does have the thrusters, and there's 6 of the thrusters, and they're 120 Newton delta V thrusters. And this, again, is how they're going to position themselves and get in and around the orbit. I'll talk about in a minute. So it has 8 5 Newton RSC thrusters and 6 of those other thrusters. The memory that's on this, which is strange, 20 gigabytes of data storage. Can you imagine? 20 gig. It's going to do all that stuff. But again, it's, again, because of the way that they're doing it, it's not taking a photo of a 25 megapixel this and that. So anyway, it's interesting that I found that's all I had for that. The thing that you see on top that looks like a satellite dish, of course, that's the high gain antenna, and that's what they're actually communicating to their mission control on Earth with. So that's basically the breakdown of the Hope spacecraft. Let's shrink that back down, and let's go over here. So basically, how it started off back in February, or back in July rather, last year, like most of them, because they all launched, I think, pretty much at the same time, because they had to get there at the same time. It takes about the same amount of time to get there. It's the same distance. So I think they all travel at the same speed. So the Hope probe launch vehicle used an MHI H-2A rocket to get it up in the air. And then the launcher speed at the first stage was 34,000 kilometers an hour. And then once it got up and started cruising, it was 121,000 kilometers an hour. I mean, I can't even fathom how fast that is. And the distance to Mars, of course, is 493 million kilometers. And the time it takes there, of course, is 7 months. So, so again, I think for all of the missions took about the same period of time. Now, I think I have one other slide. It's that one. So this is the journey here, and it's the same sort of thing that Mike showed, except that what happens with this one, it's actually going to do 2 orbits. Now, the actual orbit of Mars that this is taking is about 20,000 by 43,000 kilometers. So that's basically the orbit around Mars that this one takes. And it takes about 55 hours for this to cycle the planet. So what it's doing is actually going to be going up, and it's going to be going into orbit once it gets to Mars. It's already gotten into orbit, but it's only in a temporary orbit until it locks itself into the actual orbit that it's going to be in for the next little while. Because right now, while it got there, it's actually turning on all of its equipment and getting that up and running and making sure things are going the way that they should. A little more decade. Okay, there was just one little bit of history on this, and then I think that's pretty much it for me. Okay. Oh yeah, and this one here, it also the launch got delayed because of weather conditions. So between weather and COVID, this was quite a thing to get this up in the air. So the spacecraft dubbed Hope launched on July 19, 2020. Atop a Japanese H-2A rocket, then spent several months trekking into the red planet. On February the 9th, which just passed, needed to fire its thrusters for nearly half an hour straight to slow down enough to slip into orbit around red planet from 75,000 miles an hour down to 11,000 miles an hour. Mission personnel on the ground could only watch what happened and hope for the best. This has been a remarkable journey of humanity. UAE Space Agency Chairperson Sarah Al-Amiri said during preparations for the orbital insertion maneuver. The successful Mars orbit insertion becomes the 5th entity to reach the red planet, joining NASA, the European Space Agency, and India. Today's success also puts the $200 million spacecraft on the bright side of the grim Mars mission stats, because like Mike said earlier, more than half of these missions fail. So this is a great feat to actually get this done. Mission personnel plan to relocate the spacecraft to its science orbit in May. The science orbit will see the spacecraft circling high over the planet's equator every 55 hours, and a new orbit for Mars spacecraft that will give Hope a unique opportunity to study large-scale atmospheric phenomena on Mars. Now, the Hope mission is scheduled to last for a full Martian year, which of course is 2 years to us. The Hope spacecraft carries 3 instruments that will allow scientists to study the weather near the surface of Mars and the connections between different layers of the atmosphere and how Mars loses atmosphere to the space, which in fact Mars is losing atmosphere all the time. Scientists leading the mission hope that the data will help them understand, for example, how dust storms at the surface of Mars affect atmospheric loss and how weather systems around the globe relate to each other. The UAE has also sped into space sector. Hope launched a little more than a decade after the nation's first Earth orbiting satellite, DubaiSat-1, did so. Now, the nation has pushed space exploration as a way to develop its science and technology know-how and to buffer its economy, which is, largely built on oil. Now, there's one other thing I want to show you, and then I'm going to finish, if I can find it. Here it is. And I'm just going to put this on the screen. And I want to show you this because I find this really interesting. So this is a new project of a Mars Science City, and a new project unveiled by the United Arab Emirates and this was what's the word I'm looking for? I can't find words today. This was introduced in September 2017, and the ambitious $136 million project was launched by Vice President Sheikh Mohammed bin Rashid Al Maktoum and Crown Prince of Abu Dhabi, Sheikh Mohammed. Man, I gotta learn this stuff. Anyway, all these guys, the goal is to inspire youth to pursue careers in science and engineering as the UAE continues to position itself as an emerging player in space exploration. So this basically is something that they've built to kind of get people into what it's going to be like to live and colonize another planet. So this in itself is just an absolute amazing thing that they have done. So they are, for somebody who's never done this before, they are leaps and bounds making amazing progress in space exploration. Unbelievable. So that is my story. There. I hope that went well.
Very well. Awesome, Paul. A lot of information. Boy, we got a lot of information going here tonight.
We do.
We do. Yeah, that's some very interesting mission. I like that the science idea there. Yeah.
Yeah. They just built that, and that's just because when they colonize Mars, which I believe is everybody's hope,
mm-hmm.
They want to be able to do it here first and then replicate it up there. So.
Yeah. Awesome. Yeah, they're hitting the right path for sure. There have been a lot of missions that have broken ground to get us there, but it seems to be that we're getting better at getting to Mars anyway. Okay,
yeah, absolutely.
I'm going to try mine here quickly if I can, because I know we're into 8:47. Mine might be about 15 minutes, folks, but we'll do our best to get through it as quick as we can. And also, we're going to have a view of our waxing moon here as well this evening. So if you can hang on a little bit longer, we'll bring you a view of the moon as well. Okay, let me try this. See if this is going to work. All right, you guys can let me know if you start to see something. I got to just open up a PowerPoint presentation here. And I'm going to go slideshow from the beginning. Try to get it right this week. All right, messed up last week. How's that looking?
Yes,
good. Good.
Yep, good. Okay. All right. So, what's that?
I'm waiting to see it on Facebook.
Okay.
There it is. You're good.
Okay, great. Okay. So my talk is going to be on the Mars Perseverance rover. It was called the Mars 2020 rover until we had a young person name it Perseverance. So what an accomplishment that is to have that named after you when you send something to Mars. And also, there's this little helicopter that also went along with the Perseverance rover, and it's called Ingenuity. We're going to talk a little bit about that. So I'm just going to get my mouse in the right spot. Here we go. The primary mission now for this one was to search for signs of ancient life. We're actually going to search for signs of life this time around. Before we were looking for environments that were conducive to life, that could support life. But now we're actually going to look for those signs and to collect samples for future return to Earth. So this rover here has a drill on board, and it's going to be able to collect core samples, drill down into the surface of Mars, and then leave these samples on the surface in the tube. And hopefully down the road, we're going to be able to come up with a machine that's going to be able to go back to Mars, pick them up, and bring them back to Earth for us. They expect within the next 10 years. So the landing date of this one, of course, was February 18th, and the mission duration is at least 1 year. That'll probably be extended a whole lot more than that. So first of all, why are we landing where we are? So they landed in Jezero crater, it's called, and we're going to do a little bit of a NASA video here talking about why Jezero crater and why they believe this is one of the spots that could support some type of life.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high and are the rim of Jezero crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today.
Nope. Something happened. You still there, guys?
Yep.
Oh, what happened there? Hang on a sec.
Jezero crater formed billions of years
That's
ago.
better.
Water
Looking
filled
good
it
on
to form a
Facebook,
deep
no
lake,
issues.
about the
Yep.
same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
So that's why we're going there. One of the best locations to search for ancient life because of that large fan-shaped delta area where water would have entered the lake and would have deposited all of its material there. Okay, so what have we got going there? Well, on board the rover are a large number of scientific instruments which will measure weather variables like wind, temperature, wind speed and direction, atmospheric pressure, dust size and the shape of dust. There's also ground-penetrating radar, spectrometers, instruments that can provide imaging, chemical composition analysis, and mineralogy. An instrument that will be able to detect the presence of organic compounds in rocks and regolith from a distance, along with about 17 high-definition cameras and much, much more. So she's well equipped. And all of these experiments are not a repeat of the Curiosity rover. These are new. So because we have a new primary mission here. So what is the Mars 2020 spacecraft? Well, the spacecraft is a protective spaceship that transports a precious cargo, Perseverance, from Earth to Mars. The spacecraft is separate from the launch vehicle, the rocket that carries the spacecraft, and the rover inside it, outside of Earth's atmosphere and gravitational pull. Now, the spacecraft consists of several mechanical components: the cruise stage, the descent stage, back shell, and heat shield, plus the rover. Now, these major parts of the Mars 2020 mission spacecraft design were based on the successful Mars Science Lab mission, which delivered Curiosity rover back in August of 2012. Wow, that's been that long ago? Whew. 9 years. So we've got the cruise stage first. The cruise stage supports the whole vehicle during the 7-month cruise to Mars, keeping it powered up in communication and on target. It features a large solar array to provide power to the rover during the 7-month trip. Radio antennas keep the vehicle in contact with Earth. Fuel tanks and small thrusters on the cruise stage allow it to adjust the vehicle's courses as needed during the cruise phase. Next up is the back shell in the heat shield. Well, the back shell and heat shield together form the aero shell, they call it, which protects the rover during its turbulent descent to Mars. Now, the back shell also houses additional thrusters that fire during the guided entry portion of the descent, entry, and landing phase. And inside the top of the back shell is the canister from which the parachute is released during descent. Next, we come to the descent stage. Now, the descent stage is the rover's free-flying jetpack, which separates from the back shell and uses 8 engines to slow the final descent down. It also contains the landing radar system used to make last-minute decisions about touchdown. And just before touchdown, the descent stage lowers the rover on cables before gently placing it on the surface. Once the rover is on the ground, the descent stage flies off to make its own uncontrolled landing on the surface, a safe distance away from the rover. And finally, the rover itself. The rover is a 6-wheeled vehicle loaded with cameras and science instruments. It's designed to explore the Martian surface, making discoveries and collecting samples. And from there, we've also got this little guy, which is the next part, which we call the Mars helicopter. And the Mars helicopter Ingenuity is a technology demonstration to test powered flight on another world for the first time. It is hitching a ride on the Perseverance rover. Now, a series of flight tests will be performed over a 30 Martian day experimental window that will begin sometime in the spring of 2021. For the very first flight, the helicopter will take off just a few feet from the ground, hover in the air for about 20 to 30 seconds, and then land. That will be a major milestone. Now, the very first powered flight in the extremely thin atmosphere of Mars. After that, the team will attempt additional experimental flights of incrementally farther distances and greater altitude. And after the helicopter completes its technology demonstration, Perseverance will continue on its scientific mission. So it will take off and Perseverance will be following it. That should be a pretty cool video to see when we get to see it.
Absolutely.
Yeah.
Okay, so, go on. Here we go. So, Perseverance launched back on an Atlas V541 rocket from Launch Complex 41 at Cape Canaveral Air Force Station in Florida. The Atlas V is one of the largest rockets available for interplanetary flight. This is the same type of rocket that launched the InSight and the Curiosity to Mars. The launch vehicle was provided by United Launch Alliance. And as Mike was demonstrating earlier, the mission is timed for launch when Earth and Mars are in good positions relative to each other for landing on Mars. That is, it takes less power to travel to Mars at this time compared to other times when Earth and Mars are in different positions in their orbits. Now, as Earth and Mars orbit the Sun at different speeds and distances, once about every 26 months, they are aligned in a way that allows the most energy-efficient trip to Mars. During the cruise phase, engineers have 5 opportunities, plus 1 backup maneuver and 1 contingency maneuver to adjust the flight path. During these trajectory correction maneuvers, engineers will calculate the spacecraft's location and command 8 thrusters on the cruise stage to fire for a specific amount of time needed to tweak the path. Now, the maneuvers are very important because years of careful planning led to the selection of Jezero Crater as the landing site on Mars. And fine-tuning the flight path ensures that the spacecraft will enter the Mars atmosphere at just the right spot to land inside Jezero Crater, which is what they did. How does a helicopter fly without air? So there is air. There is a very thin atmosphere on Mars, and the rotation speed of those, I believe, are up around the thousands of RPM. They're more like a drone. And so, how do we do this? Well, how do you land a 1-ton rover on the surface of Mars? It takes a number of precisely calculated steps. The entry, descent, and landing stage, or the EDL, or what's called the 7 minutes of terror by the JPL crew. Well, the first step is called stage separation, and this happens about 3,550 kilometers from the landing site and about 1,600 kilometers above the surface of Mars. About 10 minutes before Perseverance entered the atmosphere and 16 minutes before touchdown, when its speed had reached 16,000 kilometers per hour. The spacecraft sheds its cruise stage, which houses the solar panels and fuel tanks on its trip to Mars. Next is the entry interface point. And then as it begins to descend through the atmosphere, the spacecraft encounters pockets of air that are more or less dense, which can nudge it off course. To compensate, it fires small thrusters. Then 20 seconds after that, it drops to a speed of 600 kilometers per hour, and the altitude is now down to 9 kilometers. Next thing will be the parachute deployed. At a speed of about 1,500 kilometers per hour, the parachute deploys, and 20 seconds after the parachute deploy, the heat shield separates, which we'll see coming up. We're still flying along there, dropping the speed down to 600 kilometers per hour from 1,500 kilometers per hour. That's still fast. 20 seconds after parachute deploy, the heat shield separates, allowing the spacecraft to start snap pictures of the ground. Now we're just 2 minutes away from landing. That's a bit loud.
It's kind of like a hockey game.
I I just turned the sound down a bit, and that's why it's delaying here for a second. So we'll see if it can keep up. At about 1 minute from the landing and 3.5 kilometers from the surface, the back shell separates. The rover, with its own descent engines, begins free flying. And then at 20 meters above the landing site, the sky crane is initiated, lowering the rover to a safe 2.7 kilometer an hour landing. Here comes the sky crane. Now, once the landing is detected, the rover quickly cuts the cables, allowing the descent stage to fly off to a safe distance, and that's how we land on Mars. That takes a lot of engineering.
That's unbelievable.
Yeah.
And we've done it twice now, so this is the good thing. And there it is, sitting in the center of the Jezero crater, where it'll spend the next at least year. These things don't move around very quickly either. They move on as fast as a caterpillar, so. But we don't need to move it very quickly. We don't really want to anyway. We want to stop and look at things. Anyway, that took a lot. Okay, so what have we learned so far? Well, as of last night, we had these raw images taken by the front and rear hazard cams mounted just near the bottom of the rover. So we're already getting detailed pictures back. There's supposed to be a whole lot more coming back today, actually. Then this spectacular image captured from the descent stage just before the rover touched down on the surface of Mars. This image was captured by the high-res camera on the Mars Reconnaissance Orbiter. Oh, I'm sorry, this isn't it. No, this is the other one. That's the one that was captured by the shield, or the shield above. The descent. Thank you. The descent stage. Yes. So you can see here dust blowing all over the place from the engines. So that's why they do use the sky crane, because if they had brought that down close to the ground, we'd have this covered with dust right immediately, right? So next photo. That's the one I wanted. So this one was captured by the high-res camera on the Mars Reconnaissance Orbiter. It actually shows the parachute. It was captured about 700 kilometers from Perseverance, and it traveling at 3 kilometers per second, or 10,800 kilometers per hour when it took this picture. Now, the extreme distance and high speeds of the two spacecraft were challenging conditions that required precise timing, and for Mars Reconnaissance Orbiter to both pitch upward and roll hard to the left so that Perseverance was viewable by the camera at just the right moment. Tell me that didn't take some planning. And that's an amazing capture. There's another better view of it. And finally, we got this image taken of the front wheel, but with some intriguing looking rocks nearby there. So looks like volcanic rock, actually. So NASA is also suggesting an HD video of the complete landing procedure, including sound, is on its way this week. So stay tuned. There's a whole lot more to come. Well, that's my view.
Well, that's quite a story.
Yeah, it's an amazing mission, I think. There's going to be a whole lot of data coming out of the spacecraft from Mars very shortly. And we'll stop presenting.
Wow.
So yeah, that's what's happening at Mars in the past week, right? All of that stuff. I think they actually released some images today. They're supposed to this afternoon. There's supposed to be another news conference this afternoon where they're supposed to release more images, but they're kind of holding off on the video because it takes so long to bring that video down, and the scientists want some images there to take a look at right quickly. So that's why the black and white instead of the color. That's why no video yet, but it'll all come because it all helps support the mission, right? And it helps to put that information out there to the public too, so they tend to support it.
Absolutely. I just find the whole thing amazing. That we're finally doing this, and if in 10 years' time this is, or what Elon Musk is saying is going to happen, or at least we're getting that much closer to it. Anybody who's in their 20s now,
yeah,
they probably, if they have it in their, in their foresight to be in the space projects, my gosh, they'll be going back and forth.
Absolutely.
I'm sure there'll be just missions of just traveling in space. Take however long, 7 months to get there, 7 months to get back.
Yep.
14 months, so take a year and a half cruise. Go live in space and come back. Almost like a cruise, right?
Yeah.
Except a very extended one.
Yeah. I
So,
think you got to stay there a little bit longer.
I think all these possibilities, it just blows my mind.
Oh, it's incredible where we're headed. In the next little while, all this knowledge is all coming together very quickly. Like it's exponential, it seems. There was a few things mentioned on here. Okay, Renat said 1% atmosphere density compared to that on Earth. That's right, Renat. That's why they had to go from that's why they couldn't use the parachute to bring it all the way to the surface. They had to use this jetpack to slow it down quite a bit. Where do the parts go? Example, the parachute. Do they float into space? Actually, they land on the ground, Don. So what happened? If you can go back to the Mars Reconnaissance Orbiter. That's the spacecraft that's orbiting Mars right now, and it took high definition photos of Mars Curiosity rover and all of the pieces that landed on the ground, like the heat shield and the jetpack and the parachute. They're all laying there, and they took photos of each of the pieces. So. Comb your hair after that flight, Chris. I bet. NASA Ames was big in the development of this. Danny Gallivan. Yeah, that's a compliment. I'll take that one. Thanks. I remember Danny Gallivan.
It did sound like a play-by-play. That was pretty good.
Sure. Yeah. Well, yeah, it was a lot to squeeze in there in that short period of time. So yeah, I mean, we've got a lot happening with Mars. I know we're 9:06, folks. Do we want to take a quick view of the moon here?
Hey, if they want to stick around, I'm on it and Paul's on it. So.
Okay, so yeah, we can take another 10 minutes or so. We'll offer a view here for everybody.
Yeah, you go ahead and show first, Mike, if you like.
It's okay.
So I'm not sure how fast those blades are moving on the helicopter for
20,000 RPM.
20,000 RPM. Thank you.
20,000.
That's crazy. But even to be able to fly over it and look down on Mars is going to be amazing. Even this is just a demonstration of the technology, whether it'll work. But maybe the next trip up, they'll actually have these more of them. Here we are, our waxing gibbous moon site tonight. Beautiful shot there, Mike. Mike's doing this live from his observatory here in St. John.
Like Paul said, it's placed in probably the best possible place it could be to get a shot of it, almost straight up.
Of course, right now the moon is sitting right in the middle of the winter circle. So all of those stars that make up the winter circle that surround Orion are part of this. So we've got Mars in there, we've got the moon in there, we've got Orion, we've got Sirius as part of the winter circle, we've got Gemini at the top, Auriga. Help me out, guys. Taurus, Aldebaran. There's a whole lot in that winter circle.
Endless.
It's washing out all of them. She's bright tonight.
She is bright, yeah. Hey, that's okay, Maggie. Thanks for joining us. Maggie says she's got to head out, so yeah, we're just hanging on here to offer a view here for some people who would like to stay with us for a few more minutes. Waxing gibbous moon. Waxing because it's getting larger in our sky. Gibbous because it's larger than half of illuminated. So it's heading towards the full moon. I think it's on the 27th. So we're not very far away from that.
Yeah, last, Friday was it we were on? And it was cutting right through here.
Right.
The Terminator.
Yeah.
So, in a couple of days, that's how much she opens up. It's quite impressive.
Lisa had mentioned on a message through my Gmail account there to because we're always asking for topics, right, for future shows. So she mentioned the Lunar X. So we'll take a week sometime down the road, and we'll talk about some of the main features that we see at each day coming through. The Lunar X is a really nice one. Lunar X, Lunar V are visible pretty well right around the same time.
There's a Lunar L.
Lunar L, yeah.
Yeah. Lunar S. There's that M, the signature M.
Yeah.
The cursive M that's on there.
Is that the McDonald's sign, you mean, or is that?
There's the T-Rex.
That's not a big yellow M, is it?
That's right for the Tim Hortons.
Yeah.
Anybody that's never seen the T-Rex, here's his head with his eye, comes down to his back, the little forward-facing arms right in here, comes down to his legs, and then his butt, and dinosaur do over there.
Do.
That is a T-Rex. On
Do da da da.
I've never seen the man in the moon, so I just cannot see it. I've never seen it. It doesn't pop out for me for some reason.
Really?
We'll have to get Kurt to send you a picture.
I've looked at numerous pictures online, and I still look up the moon and go, yeah, no, it's like the wild duck cluster to me. I don't see it.
So Paul's asking here. Paul Crowder's asking, what rig are you using to shoot the moon, Mike?
Well, why don't I do this? I can show you what rig I'm using, hopefully.
We'll bring it up here for you, Paul.
Bring it up here and go full screen.
So that's a live shot, IR shot inside his observatory.
So that's it's a 110 Orion ED with a 777 millimeter focal length. And on top of it, of course, a guide scope and guide camera, but I'm not guiding right now because it's the moon. But all sits on an EQ5 mount in my observatory. So that's what's shooting the moon right now. Now, see if I can get rid of this piece. There we go. And back to the moon.
Any questions out there about the moon or what we're looking at or what we've already talked about?
That's amore.
Renat says the helicopter's not that heavy. No, it's really not. It's very light, and they had to make it light because they need it to. They had these 30,000 RPM blades, but it's very tiny, because it's just a demonstration of whether or not they can do it. Right. So it does have HD cameras on it, though. It's going to take some pictures of itself flying across the Martian surface, shadows, and that kind of thing. So.
Little Martian sunbathing. Here's this. They better run it back.
So Renat's asking, what are these? Well, in Renat, there are a lot of things on the moon. That there's Wilma Flintstones on the moon. There's the dinosaur, T-Rex. There's the man on the moon. And these are all things that we like to show kids when they come by the scope, and bigger kids too.
What I'm going to do is I'm not going to show the moon live. I'm just going to show you a picture that I just got finished taking. Not now, whenever you guys are done. Mm-hmm. But I want to show you how fast I did this. I did this just after we finished our Renaissance, our Perseverance and Hope and Taiwan Yanwan talk. And anyway, it's kind of
I did the same thing and posted it on my Facebook page while you were talking about yours. And that was like you. I only did 100 frames.
You're spoiled. Both of you are spoiled. You're just sitting in there taking a nice photo and then sending it up on Facebook or whatever. And, you're making people think that you were outside in the cold tonight, but you really weren't.
Oh, no, never.
Not anymore.
You go ahead and show your photograph and show how simple it is there to with the equipment that we've got to do that.
Okay.
I said mine was 100 frames stacked and posted it.
Okay, I'll show you.
If yours is better, then I'll take mine down.
Don't do that.
Well, I'll show you what I'm shooting with first. So there's my rig. And so mine, it's very similar to Mike's, to be totally frank.
That's my first name, Frank.
I'm using a AFI 294 cooled astronomy camera. I'm using a 105 millimeter, which is the diameter, and it's a 735 millimeter focal length refractor, and it mounts on a EQ6R mount, which is mounted to a permanent pier. And it's got all the power rigging and all that stuff to run it and make it go. And I can operate it from here within the house. That's my house up there, and I'm pointing at. The moon was almost straight up. In fact, like Mike said, it's placed so well tonight. Anyway, that's what I'm shooting it with. Now I'll stop presenting and I'll show you the picture I just took. present now your entire screen and this one right here. And we can take a little walk around it if, Chris, you want to talk about some of the features.
Ooh, wow. Well, I'll have to zoom in a little bit.
Yeah, I just took mine down.
Okay. How did you capture that, Paul?
Okay, so all I did is I took 200 frames, and I did it in sharp cap, which is what we're actually presenting on, and then I just stacked them in auto stacker and did what I had to do with it, and then I threw it into Photoshop, which is where it is right now, and I just basically just added some contrast and some sharpness and some detail so you could actually see what's going on the moon. I like to make mine a little darker than lighter because then you can start to see a lot of the the surface other than craters that you typically wouldn't see a lot, like the rills, like over here, that stands out considerably well. When you look at the Apennine mountain ranges, they really pop out nicely. Copernicus.
Yeah.
You can see that I think there's 3 mountain ranges in there, but I'm seeing 2, and of course the Terrace Walls. So there's lots to look at. But besides that, there's lots of ejecta that's hard to see unless you get the right contrast. So when you see those white lines that look almost like a basketball, those lines that are just reaching out and out and out, you can see that in there. You can see lots of ejecta going on here. So there's all kinds of things that you can see if the image is just a little bit more contrasty and dark, so that when you're putting in the highlights and the darker areas, they tend to stand out more, I find.
Yeah. Fascinating view there. Lots of detail.
Yeah.
Again, that beautiful view of the mountain range there. And Eratosthenes is the crater that sits just at the end of it there.
Right here?
Yep. That's the Apennine Mountains in front of it. And Eratosthenes was, of course, the person who first calculated the circumference of the Earth to within a pretty close distance, actually. This is a young and isolated formation with hexagonal form, bright rays all around, very steep slopes, dominant Marin stellarium of 900 meters, floor flattened to the north and flatter to the north and to the south. 3 central mountains of 1.2 kilometers each. And it is from the Copernican period of about 1.1 billion years old. Dimensions are 93 by 93 kilometers. 93 kilometers in diameter.
She's pretty round, eh?
Pretty round. And she's 11,400 feet deep. That's something unreal.
Yeah, 11,000 feet. So that's almost 3 miles.
Yeah.
It's a little better than 2 miles, actually.
Deep, yeah.
Deep, yeah.
I mean, these asteroids and comets hit the moon with such a force, right? They're releasing all their energy all at once, because there was really not much there to slow them down at all. They come in at their full speed because the moon is basically airless. And I mean, a lot of those that may have impacted us would have been burnt up in our atmosphere, or at least broken up in our atmosphere. But the moon, of course, doesn't have that, and we're looking back billions of years here. We're on our planet, of course, we've got weather that changes. The ones that do exist here on the planet that we can see have weathered over time, and of course, a lot of them, with our planet about 70% water, a lot of them would just land in the ocean, and we never get a chance to see them. But here we've got, an actual view of the destruction that actually happens in our solar system from time to time.
Mike says he's never seen the man in the moon. I'm going to point it out to you, Mike, and maybe you can see it if you just use a little imagination.
Yeah.
Well, this is the mouth right here, and he's going, oh, right? That's a big O mouth. There's his nose, right? Here's one eye. Here's the other eye.
Yeah, no.
You got no imagination.
No, I guess not.
You can't see that. An
Yeah,
eyeball, a second eyeball, a nose because it sticks out, looks like it's protruding, and a mouth, and of course his head. He looks like what was that basketball that when Buddy was stuck on the island? Wilson.
Oh, Wilson. Wilson. Yeah.
Wilson. That's him. Looks like Wilson.
Yeah.
Anyway,
Renat's asking about are the three mountains asteroid leftovers? Well, no, not really, because those mountains popped up probably from these large maria here, these large dark areas that we see right in here and in here, when something awful big hit the moon in its early days, probably popped these mountains up at the same time. Now, something like Copernicus, though, I mean, we look at Copernicus there, that really stands out. It's actually one of the better features that are available during a full moon as well. That crater is about 100 kilometers across, and it has a mountain peak in it that's about 2 kilometers high. Maybe you can zoom in on that one, Paul. There we go. So you can see the mountain peak inside that one, and you can see what would have happened was that a large comet or asteroid would have hit the moon, it would have bounced out this way, and then that energy would have been re-released back up to pop that mountain up in the center there, all in about a couple of seconds.
you and Mike too on Friday were talking about the Terrace Walls,
Yes.
and you can really see them there. I'm just taking my mouse and just going back and forth.
Mm-hmm.
I don't know if you can see that or not.
Yep. Yeah.
So that just gives you an idea of the depth, because we were talking about this crater being you were saying 11,000 feet or almost 12,000 feet.
Yeah, actually, that is Copernicus that I was talking about. I'm sorry. I'm sorry. No, I wasn't. I didn't mean to be, but it is Copernicus's information. So Copernicus is 93 kilometers in diameter, and it is 11,400 feet deep.
So that would be St. John de Moncton.
Right, would fit inside that.
Yeah, and people are always asking, "Can you see a flag? Can you see this? Can you see that?" Well, think about it now. You're driving from St. John de Moncton. And think about how far that is. And if I'm going to plunk a flag, say in Petty-Kodiak, and think how small the flag is in relation to that distance, it's impossible. We don't have the earthly capabilities to see that resolution.
Yeah. No. And the detail there tonight is great because we've got a lot of shadowing going on there too as we get closer to the Terminator line, of course. You can see some of them there. They're the detail up in that. Southern pole is really fascinating. Lots of detail in here. Almost everything on the moon was a crater at one time, or is a crater. There are over 300,000 craters on the side of the moon that we look at that are 1 kilometer or larger. So, I mean, take 1 kilometer now. So, okay, so we said this one is almost 100 kilometers. So how big is 1 kilometer?
So
pretty tiny.
1/100th of that.
Yeah, so I mean even that little tiny one right there is not 100th of a kilometer, or 1 kilometer. So it'd be smaller than that even. So that's a kilometer. So how big is the rover? 3 meters, right?
Right.
3 meters long. So yeah, you can't pick up anything. There is a calculation that was already done to get the resolving power that required to be able to view the rover on the surface of the moon, and it was incredible, like a huge size.
You can see the straight wall there too, still, right?
There, yeah, right, actually.
Sword handle.
Yeah.
And there's the straight wall right there.
Corpus Rectus, it's 110 kilometers long, so it's actually a fault line on the moon. So we can see that little line there, yeah. Can we zoom in a bit more, Paul? Or, yeah.
I can try to. It'll probably start to pixelize after this.
Okay.
There it is.
Oh,
there it is.
There it is right there, yeah. So that's a sword. Kind of like, it looks like a sword with a handle there up in the top right. And that's called, and that's visible right around this day, around these couple of days, right around just after first quarter. We're actually right around first quarter. So what that is a fault line on the moon. Now, if you were standing there at that point, you'd be standing on a hill basically, and it would be just a gentle slope going down. So what has happened is part of it has dropped, right? Of course, and it's 110 kilometers long. So there we go. There again, there's 110 kilometers. So what's a kilometer crater? What's a 1 kilometer crater compared to that?
So that's 100. So 1/100th.
Yeah.
It's probably not even visible.
Not even visible, yeah, at that scale.
Yeah, it would be like just a tiny, tiny little fraction of a dot.
So that little one right in front of it there, in about the middle, that's probably about 5 kilometers or so.
That would be that'd be about 5% of that. That'd be 5 kilometers. So divide that by 5.
Yeah, there you go. So I mean, it looks like it's a crack in the moon's surface, but really what's happening there is it's the light that's hitting the opposite side of the moon there, of course, up on the left-hand side, that's causing that shadowing effect. And the closer we get to the terminator line, the more prominent that is. So a couple of days earlier than this, that would have been very, very, very prominent. But again, we start to lose those features as the moon gets to full, because the moon is basically shining straight down on everything. And in that case, we don't get as many shadows. Look at that Copernicus standing right out there. But
yeah,
that's beautiful.
You see all the
ejecta
and all
Yeah.
the background there.
Yeah.
And you can see how high that wall built up is, huh?
Yeah, you can see the center. So that terraced walls thing is the fact that the crater has actually dropped like this, in center. So
Yeah. And then on the other opposite side, is that Plato right here?
that's Plato right there. Yeah.
And I'm not sure what the stats is on that, but
Yeah, I can bring it up
that's
here for
another
you.
large crater. They look to be about the same size. Maybe Plato might be a little bigger, maybe.
Plato, I'll click on it right here. I got some data coming up. I got a moon map here, Virtual Moon Atlas, which is an excellent program. I've got that up right now, looking at some data. So it's 101 by 101 kilometers, so about 101 kilometers in diameter.
So they're similar now.
Yeah. And it's back from the Upper Imbrium time frame, so about 3.8 billion years ago. That one was from. Pretty steep slopes supporting Platon G to the east. Few high walls with 2-kilometer summits and a collapsed part to the west. An immense flat floor filled with lava.
No peak on that one, eh?
No peak in that one, no. And of course, that's right on the edge of Mare Imbrium, which is. These were all mare, but that mare word is the Latin word for seas, because when they looked up at the moon, of course, long ago, they thought these were oceans. We actually have one called Oceanus Procellarum, which is the largest maria on the moon. And maria are just large areas that were impacted back in the moon's early days. And when they were impacted, it broke through the moon's early crust. Lava was brought up from underneath the surface. That lava filled in these large areas. That lava would eventually cool and then darken, and that's why we have these maria. And that most of the moon is covered. Well, the moon is covered with basalt, and in these maria area especially, it's fairly deep. It looks like a powdered concrete, basically. What virtual moon map am I using? It's called Virtual Moon Atlas. Vontrash 15, and it's a free program. It has a lot in it. I'm only beginning to learn how to use it, but you can zoom in and out, and it'll bring up those specific features in that part of the moon that you're looking at. There's some details that you can click on to bring up a little bit of factual information on them, and it can do a whole lot more than that. I just haven't had the time to get into more of it, but.
Did you find another target, Mike?
Yeah, no. I'm just messing around here. I'm in the middle of sleuthing.
Okay. So that's basically that photograph there. So I'll just I'll post that on Facebook. But that's how easy it is. Like once you get used to pushing a few buttons, and the moon. I can't recommend it enough for anybody getting into photographing the night sky. Start with the moon, because you have so many opportunities in a run of a month. You have so many different phases. You can learn a lot about exposures, especially if you're starting out with Mike and Chris got that really, really thin, what was it, 11-hour-old moon this
Yeah.
month?
Yeah, it was about 1% or 1.4%.
Yeah, I think
One
it was the 26 hour I think we caught, but we caught it younger
Yeah.
last month. Yeah, I think it was around 16 hours last month.
It was that's just amazing. But if you were to photograph something like that, your your settings are going to be way different because you're trying to capture something that's very, very, very dim. And then all of a sudden you're photographing something like this, which is really bright because as it gets larger, it's reflecting more light. And that's why on full moon nights, you don't need to have your car lights on. You can drive with them off because there's so much light coming off the moon. So to photograph something like this just takes basically a change in the exposure that you're taking it. So just little things like that. Once you know a few things like that, you can take photographs of this stuff, and the moon is so much fun to photograph. And if you want to learn things about the moon, take some of your photos, blow them up, and then just start looking for features and stuff. And then all of a sudden, your photographic enjoyment becomes a little scientific too.
Awesome. So I'm just going to go through some of the comments here before we sign off at all. Sandy says, my favorite online astro place. Awesome. Not just because you're Maritimers, but because you cover astro stuff while being receptive. We like to be. Thanks. Thanks for joining us. Have there been any caves discovered yet on the moon? I don't know for sure.
Yes.
Have there?
There have.
Awesome. There is one in that Beans commercial, because that's where that monster comes up out of that. He comes up out of the cave, doesn't he? We'll have to play that sometime again. Yeah.
No, where there was lava, they've actually found something similar to lava tubes.
Okay.
So.
Oh, we're stop sharing. Sorry.
Or it could be the
That's
ventilation system for the hollow moon. I don't know which yet. But.
Oh, don't stop yet, Paul. That's fine. Or unless
Well,
Mike's got something.
I think Mike's on something now.
Okay. Mike's not on anything right now.
Oh, sorry. My apologies.
Have tried colorizing yet, Paul Vernal asks. Have you tried colorizing the moon at any time with your shots?
Colorizing?
Colorizing?
Oh, colorizing.
Yes,
oh,
sorry.
sorry.
Yeah.
Yeah, I have a few times actually. For stuff like this, I just kind of shoot it in monochrome.
Mm-hmm.
But yeah, no, I shot the moon lots with color and stuff. And there's a lot of really cool colors on the moon. There are a variety of colors from all the different materials that are on there. You'll get some greens and some tans and a little blues almost. So there's a lot of different color up there. I just didn't bother doing that tonight.
Really brings it alive for sure. Sandy says she's using a Celestron Edge 9 1/4 on a CGEM DX plus an ASI 1160 millimeter. Or
do you have orange feet?
What's that?
Does she have orange feet?
Celestron, she probably does.
That's my setup.
Am I sharing the right screen?
You're sharing the moon.
I see the moon.
Okay.
Yep.
Yeah.
Awesome. Yep. That's amazing capture. Yeah. So that's a beautiful scope, Sandy.
Yes, it is.
Yeah. That's right in the sweet spot, right? The 9 1/4 for the Celestron.
I got one behind me.
Yeah. I get the 11-inch, the Celestron CPC 11. Mike's got the 9 1/4. I've got the 8, but the 9 1/4 seems to be the real sweet spot for those really crisp, nice images. The 11 doesn't do too bad, but 11 is just a lot of work to set up. It's not a grab and go for sure.
Does it look like this
What's she
one?
running it on? AVX?
What's that? She says a CGEM.
Oh, a CGEM. Oh,
CGEM
wow.
DX plus an ASI 1160 mm or 071 MC. I don't. You guys must know what that is. Camera.
Yeah, she's got a color camera and a mono camera.
Right.
Let me present something here.
I got an Android camera. That's mine.
Let me present for a second, Paul.
Sure.
Yeah, let me just.
Not an object.
Oh, there we go.
Doop, doop, doop. That's good, but it looks like this one.
Hey, there you are.
Yeah, there's a rig.
Yeah. So that's Mike's rig as he had set up at our St. John Astronomy Club meeting one night. Back when we used to get together as a group, not do this kind of thing.
Yeah.
We used to get in and talk about. We'd have a.
Show us your scope.
Telescope of the month kind of thing, and it was great because you got to see other people's gear and you could go over and hit it with a hammer and stuff like that, just to see if it could stand up.
That telescope was always a star party showstopper. Wherever we went,
Yeah.
People just wanted to look through that because Mike's got it. I mean, it's awesome gear to begin with, but he always dresses them up so nice. Eh?
Yeah.
Just matches, yeah. I'd like to see some of the photographs they get through that 9.25.
Yeah.
Minivan.
If you just had
Most
orange feet, it would set it right off.
orange feet, yeah. I gotta get. If she's got them, I'll go take them.
The running joke there is that my scope is all black, but it came with orange feet. And Mike's scope is orange, but it didn't come with orange feet. So he keeps threatening to take the feet off my telescope and use them. Anyway, he could have them if he wants them. I could care less. I'll just get my dog out behind me. Jamie says, I tried to observe the moon tonight, but it was way too high up in the sky. Jamie, you got to get your lawn chair out. No, it's a difficult target, really is, when you're bent way back like that, trying to look up at it for sure. But give it a few more nights, it'll move itself farther over to the eastern part of the sky, start dropping. Wow, a long way from the first adventure listing to the from Sputnik 1 for sure, Bob. Yeah. We've come a long way since then, and we're only amateurs, imagine what they're doing at JPL tonight. I remember Sputnik, Renat, as well. Super photo of the moon for sure, Sandy. Mountains form an arc from Aristophanes to Plato. Could the Maria be an ancient crater? It actually is an ancient crater for sure. And it's a huge. I mean, these Maria are not level; they're deep, right? So they are craters. And a matter of, there's very little on the moon that is not a crater. Can one of you guys bring up your picture of the moon again?
Yeah, just a sec here. I gotta figure out where it went.
Perhaps a live talk through Virtual Moon Atlas one of these nights. Yeah, that'd be another good talk, Renat, for sure. It is a great program. There's a lot in there. I wish I could spend more time on it, but I still got a job I gotta do. Sandy's got a C11 as well. Awesome.
Okay, I just gotta figure out how to share my screen again. I had to move it right over top of. Entire screen.
Awesome. Thanks, Don, for joining us. As a beginner, my astronomy certification test won't let me buy a telescope yet. That'll come. You know something? The sky's not going anywhere, so you get lots of time.
This is the live version.
Right. What a difference, eh?
Yeah. Well, that's the thing about when you photograph stuff. You can always make it look prettier and more detailed.
Still looks great.
Oh, I still can't look at.
So what was I talking about? Why did I want you to look at? We're looking at the. I'm losing my questions. I got two screens with questions coming in. Mountains form an arc from Aristophanes to Plato. Yeah. So if we look at the moon, maybe Paul, anywhere, you just zoom in there, anywhere at all. Yeah. You can see that there are areas maybe over there to your right, Paul. Yeah, in that area, just. Zoom in there a little bit.
Yeah, one sec here. 150.
What I really wanted to do was just kind of show. Maybe you can see my mouse on the screen. I think I can. You can't, but I think they can. So I was just kind of showing some of the craters in there that are kind of flattened out, and those would be the more ancient, more ancient type craters.
Yeah.
And then. Inside those craters, if you could zoom in just a bit more, I know we're not worried about pixelating. I'm just kind of, there we go. So even inside those craters, you can see that there are some newer ones in there. And of course, a crater inside a crater is going to mean that those ones happened in a date closer to our time. So there are some really flat areas there where they've been, they've been weathered over time. Yeah, right. Yeah.
So you see how that's almost like two cats here?
Right.
That's another crater within this crater. And then there's another one that impacted, it looks like, afterwards.
Right. So we can tell the age of them partly that way because, there is weathering on the moon, and that's basically because there's about 100 tons of micrometeorites, space dust, that impacts the moon every single day. So that's why the rocks on the moon are becoming pulverized, basically. A lot of them are pulverized down into the texture of, say, powdered concrete. When Neil Armstrong came down from the LEM, when he first looked down at the surface of the moon, he said it looks like a talcum powder, and it was very, very fine. And that's just because of the moon being completely exposed and micrometeorites bombarding it over millions of years. So that's what would weather a lot of these craters down. And then craters inside of those craters, which are inside of some other craters, so you've got 2, 3, 4 layers of craters there. So almost everything on the moon is a crater. No matter if they're a large Maria or they're just the tiniest micro crater. There's a talk on them. Who did a talk on it? Mike, did you do a talk on craters at the St. John Astronomy Club once? The different types of craters?
Well, we did the course, and then when we talked about the moon course, and then when we talked about craters, we talked about the different types and how some are layered and some are not, and the depths and the centers and how they're formed. Yeah,
we might do a talk on that sometime here on the show.
I have a PowerPoint presentation somewhere on the moon that I should post one of these days.
Awesome.
It's not made of cheese.
Well, we're not sure. I haven't been there, so I'm not sure. I believe it isn't, but.
I believe. Yeah. All right, well, we're running.
Okay,
up
I think we're pretty well close to calling it an evening. So I want to thank everybody on here tonight for joining us. I guess we'll get into our closing comments here. Thanks for the awesome views, guys. Really nice. So in closing tonight, folks, our special thanks again for your continued support out there. Thanks again to Rosanna, of course, for her continued contributions to our show. Always a great, interesting topic there. Thanks as well to all the great folks at Astronomy. Thanks as well to all the great folks at Astronomy Plus for sponsoring our weekly broadcast here. And remember, too, we do love getting your photos, so send them into SundayNightAstronomyShow@gmail.com. One long word, but we accept it. Or send them into my Facebook page, too, if you like. And we'll be happy to include them on our next broadcast. Also, that we're looking for suggestions for topics for future shows. I am writing them down as we get them. We've got a nice little list there, about 10 or 12 things that we're going to talk about in future episodes. So if you have anything that you'd like us to talk about on a future episode, just send your request to the same address, SundayNightAstronomyShow@gmail.com, and we'll be happy to include it on our broadcast. So we also like to ask you that if you enjoyed the content here tonight and you joined us from YouTube, please consider giving us a subscribe and like on our channel. And please let your family and friends know as well that we are here every Sunday night at the same time, Atlantic time right now, Atlantic Standard Time, 8 o'clock, to help educate you and entertain you a bit for the evening on the night sky and our passion. So for now then, from Paul, Mike, and I, stay safe, everybody out there. We wish you all clear skies, and we hope to see you again here next week. And as we like to say, guys, keep your scopes pointed up.
Where's that music?
Yeah, here it comes. There it is. Bopping, guys, bopping heads. Yeah. Good evening, everyone. Take care. Have a great week.